Hello, good afternoon.
Good afternoon.
Good afternoon, sir.
Yes, so how are you doing with Gumamulugo?
Yeah, okay.
So you are okay. So I think you were prepared, eh?
For the Rockland.
Yes, we've been suspecting it for long time.
Yeah,
Yeah. So some people putting some good videos, but we are not yet to listen to the videos. So well and good. So let's go straight to the point. So as I communicated before, we discussed today abstract classes and the interfaces. And after those two topics, next we'll discuss things like a list. And after list, we'll be ready to sit for exam. So I think we need to get used. And good enough for every session we have, we prepared the record and we uploaded the record. So I believe that you were able to download some previous record from YouTube that I shared with you. So you can keep sharing those ones with even other friends as long as you want them to be aware of what we have covered. So today topics are very simple, but before we talk about today's topic, I shared with you some work on inheritance, yeah, specifically inheritance. So if you got the work from WhatsApp group, please take your time and work on it. And if you have some issues, you can feel free to ask me or to ask Bonnet. So we'll be ready to support. So for sure, as soon as the lockdown is over, for me, if I meet with you face to face, that will be for exam. If you haven't done your mid-sem yet, you will do the mid-sem today, and probably 3 4 days after we come again for the final exam. So you remember we need to finish this semester by mid-August. So we remain like with 4 weeks to finish our semester. So don't blame anyone. You have a content, you have a recorded material, you know what you should be doing. So you make sure that all those concepts that we discuss, you really revise, practice, and understand. All right. So today's topic is we start with the abstract classes, and once we finish the abstract classes, we go for interfaces. So let's go straight to the point. Let's go straight to the point. So in this reason, I want you to understand what we mean by abstract class. I want you to understand why we need abstract classes, and then how do we declare abstract classes, and then understand the clear difference between abstract class and a concrete class. So I think if it is your first time to hear this one, when a class is declared using abstract keyword, so basically that means your class is abstract. So what does it mean? If a class is abstract, this class will contain what you call abstract method. So what do we mean by abstract method? So abstract method is any method with no implementation. So here we say method without body. So when you say something like void void show name, for example, show name. So you have a method like this one, and you remember when you do this, what comes next? You open and you close and you put definition of your method. I think you understand what I mean. So in the case of abstract class, it's not like this one. So sorry, I want to erase. So in the case of abstract class, it's not like that. So simply what you have something like this one. So your method does not have any body. So there is no implementation for your method. So if your method does not have any body, that method is known as abstract method. So you can only define abstract method inside abstract classes. But also remember that abstract class can contain both abstract method and concrete method. So what's concrete method? Method with body. If I say void blah blah blah, and I put like this one, then I put the implementation opening and closing. This is what we call a concrete method. So abstract method and abstract method and the concrete methods can both exist in one class, and as long as that class contain abstract method, then it's called also abstract class. So this is very important. So if you have abstract method, abstract class, cannot be instantiated. What does it mean? You cannot create object of that class. So if you have like a class, abstract class A, you have abstract keyword, abstract class A, and among a method you have, there is abstract method like this one. You cannot say a whatever new A. You cannot do that because it is abstract class. You cannot instantiate it. So I think you understand what I mean. So why do we need abstract class then? Because we can simply use a class without a keyword abstract. But if we do so, if you don't have abstract class, the class is concrete. So now you understand. Your class, it's either abstract or it's a concrete. So we need abstract class specifically when we define a superclass. You remember when we discussed the concept of inheritance? You have a superclass and subclasses. And in most cases, when your superclass has a method and your subclass is going to extend your superclass, if you have the same method, we override the method. But when you use abstract class, it allows you to force, to make sure that every subclass, every child class will provide its specific implementation of some general abstract method. So why do you wait for subclass to override a method of superclass? Because sometimes the programmers might not remember to do that. You see the method like show the marks in the superclass. You may not think it's very important to override it in your subclass. So if you don't override it, that means you are using the method from a superclass. So if you have like so many subclasses, you may expect some changes from a subclass in terms of the body of your method. So the only way to force this one is to leave that method unimplemented in a superclass. And when you leave it unimplemented, when you leave it with no implementation, you need to make it abstract. So once you make it abstract, automatically the class becomes also abstract. So in this case, if a child class does not implement the abstract method from a superclass, the child class must need to be declared also as abstract. So the point is, you can only be able to instantiate or to create instance of any class if that class has no abstract method. If that class is inheriting from another class which is abstract, you make sure that that class is going to implement all the methods from the superclass. And this will allow you to create a class that should not be used to create an object. So again, if you want to have your class and you do not want any programmer to make object of that class, still you can go ahead and make that class abstract as well. So look at this good example. You can see this method here. This is abstract method because there is no implementation. You can see there's no implementation, just there's a semicolon after parentheses. So because of this, the whole class will be declared as abstract. Then you have another method called info, but this method is not abstract. This one is a concrete method because there is some definition here. The definition can be empty, that's fine, as long as you have opening and closing braces. That means there is implementation for info method. So now you create another class cat. This class is extending a class animal. Definitely you need to make implementation of this method. Okay, you need to make implementation of this method. So you cannot create instance of class animal. You cannot say animal A equal to whatever, animal A equal to new animal. You cannot say that because that is an abstract class. Then for the cat, because the cat is extending animal and has implemented any unimplemented method here, yes, you can say this one you cannot do, but here you can say cat whatever A equal to new cat. So here you can do that because the abstract method is implemented. Eventually you can do that because the class is not abstract. If there is any other method here which is not implemented, now you understand what happens. You need to make this one abstract as well. So as long as it contains a method which is not implemented, the class becomes abstract. So we can look at a quick comparison between abstract class and the concrete class. Yes, when it is abstract, there is abstract keyword in the declaration. For the concrete class, you will not see the keyword abstract. You don't need this keyword. Number two, abstract class can have both abstract method and the concrete method. Can have abstract method and the concrete method. And if you look at the concrete class will only contain a concrete method. Again, abstract class cannot be used to create object. You remember what we said? You cannot create instance. You cannot create instance of abstract class. You cannot use it. So only what you do when you have abstract class, you need to extend. You need another class to extend. By the way, you cannot. Okay, abstract class cannot be used to create an object, and they cannot be useful only when they are extended by some other classes. So you need to make sure that abstract classes either they are extended. So they are only useful if they are extended by some other classes. You understand what we mean? Because when you extend abstract class, you have a room to implement any unimplemented method. For example, here it's a class A. If I say class B, then extend A, this is possible. If I say class B, extend A, so I have a room that I'm going to implement this method, which was here. All right, so okay, some people are not good. They're making too much noise. They are giving me extra work. So you understand what we mean. So for the concrete class, you can create object of those classes. That's fine. Okay. This is a quick difference. And let's look at a quick example for this topic. So before we look at the examples, let me know if you have any question about about abstract classes. So any question? Okay, you can use the chat room because I know some people are very cautious. They do not want to make a noise. But if you use a chat room, that's fine. So as long as if you have a question, you can let me know. If you have no question, you can say no question. We have a chat room here. Good. No, no. A few people are saying no. Okay. So, all right. So, apart from Rutalemala and Imbabazi, and those are two students in the class, I think. I don't know if others are still with us or if they are doing something else. But we need to help each other because teaching online is not that much simple. You need to make sure that the students are following. Yes, yes, Wase. Yes, Rebelo. All right. So looks like the topic is clear. Now let's go for some examples. So yeah, keep putting your comments on chat room. I will check. So I make a new Java project. So I believe that you did install your Eclipse. So this is I call it abstract class, concrete class, abstract class interfaces because we use the same package. All right, so this is the name of the project. Okay, so where's the project? We can go with the packages as well. I make one package for abstract. Okay, this is package. See the package. I will put some programs here related to abstract classes, and I will have another package. I have another package for interfaces because after those examples, we'll go for interfaces. So here I will make it also interfaces. Good. So we'll go for some quick examples. Okay, you did install NetBeans. That's fine, but why did you go for NetBeans? NetBeans is very heavy. Eclipse is very light, so you don't need even to install it. You download it and you extract it and you open it. But that's good. If you want to use the NetBeans, go ahead. But most of the developers worldwide, they are not using NetBeans. They are using Eclipse. If not Eclipse, they are using IntelliJ. I think IntelliJ. This is another wonderful tool, but you need to pay a license for it. So that's fine. You can go for IntelliJ. You can go for Eclipse. You can go for VC Code, Visual Studio Code. You can go for NetBeans, etc. So I don't think NetBeans is the best, but if you are familiar with that one, please go for it. That's fine. So all right. So now let's go for abstract. So let's make some classes. You can see we make a class here, and how do we call this class? Maybe I call it yeah, maybe this is Auka.
Recording in progress.
So somebody is playing my old video. Can you mute yourself? I can help you. So you guys, you like to disturb for sure. So let me call it Auka, and yes, you make it abstract. This is abstract class. So what does it mean, by the way? So once you make it abstract, it means that this class, it has to be extended. It has to be because of this keyword, it has to be extended. So you may not need the keyword public. Let's just go with like this. In this class, I will have a method. I have a simple method. Let's say, okay, public void show student details. So if I do this, if I do like this one, automatically it does understand that this is abstract class because there is no body. So you have two options. Either you add the body. So adding a body means what? You remove this one and you put the definition of your method. So whatever you put here, that will be the body of your method. So that is the definition of your method. So if you can't put the body of the method and like this one, that means your method has to be declared as abstract. So if you need to fix this one, you make sure you make it abstract, then there is no complaint. So as we said, you can have a concrete method inside your abstract method, like say public void greetings, and say maybe we say okay, system out. System out print, sorry, should go with the print line, welcome to Auka, things like this one. So now if you have by the way, we didn't make a mistake because this class should be named, the name here should have the name you use here should be the name of a class with many methods. So that's fine. I have no problem to rename this one. Refactor rename. Let me rename, and I rename it as abstract class demo. So I do not want to update the reference. If I do, it will change also the name of this class here. Rename compilation units. Let's see. No, this one should remain like Auka class. But here we can have another class, public class, and this is our class. This class will contain public static void main, and we pass our parameters as usual, whatever, something like this. Yes, so let's start with something simple. Print line abstract class demonstration. So if we run this program, that's fine. Let's see what happens. So run as a Java program, Java application. You will be able to see the output here. So you can see the output, abstract class demonstration. So remember what we said, since this one is abstract class, the first point we said was you cannot create instance of that class. You cannot do this. Alright? So why you can't do that? Because it contains abstract method. So if you mouse over here, you will see you cannot instantiate the type Auka simply because of this method. If you remove this method, then you need to remove abstract keyword here as well. So if you remove abstract keyword here, you will be able to create instance of this method. So, but remember, why do we need the abstract method? So here I have show student details, and I can have so many other classes where this method can be implemented. So by forcing the subclass to make their own implementation of this method, that prompted me to make it abstract. So let's say you have a class, something like a class B, extend AUKA, and in this class, why is it complaining? Oh, sorry, it's inside another class, so it should be outside the class. So it should come here. So why is it complaining? Why is it complaining? Because it needs to implement an implemented method. I can write the same method, or because I'm using IDE, I can simply click here and it brings that method and it's asking me to make implementation. You see? The same method, but here there is no abstract because I needed to provide implementation. So maybe this method will be implemented like this is class B. You can implement it in any way. You can put whatever the content you want. And here you have another class like a class C. Also extend AUKA. So it'll be the same. So it has to ask you to make sure that you implement any unimplemented method. If you don't implement any unimplemented method, you make sure that that class is abstract as well. So maybe I will say here system out print line class C. So now I want you to understand the point I said before. Basically, when you do this, you are forcing your classes, your subclasses, to make their own implementation of any method in a super class. Okay? So if I do nothing about the grading method in my subclass, that's fine, because it's not abstract. But if I want, I can overwrite it. I can do copy again and come here and put the same method, but I make sure I'm overriding the implementation I have in super class. But guess what? There is no obligation for me to do that. All right? There is no obligation. You can see here, I'm not having that method, and still my program is okay. So if you remember from the slide what we said, if you have an abstract method, you are forcing your subclasses, no matter how many subclasses, you are forcing your subclasses to make their own implementation of any abstract method from a super class. So now if you come here, you can create instance of B or C. You can say maybe B, that's B, new B. That's fine. You cannot complain since B is not abstract. And here you can do B, show students details. You can do B, gradings. That's fine. You can do instance of C. C, that is a C, new C. So you can do C, show student details. You can do C, gradings, something like this. So if you run your program, land of application, yes, you can see. All right. So I think you understand the purpose of abstract class, and if you do understand the purpose of abstract class, you definitely understand why we need abstract classes. So I will share with you this one after the session. So if you have any question about this one, let's see your questions in the chat room. So if you have no question, then I think you understand why we need abstract classes and when we use abstract classes. So let me know if you have any question about the topic, Otherwise, we go with interfaces. All right. So after interfaces, we not cover the whole of stuff. After interfaces, we cover interfaces like 10 slides. Then we'll be talking to some other topics later on. So we don't use abstract classes if we don't mind about those kind of constraints I was specifying. Number one, if you want any other class to be able to instantiate your class, to create object of your class, you cannot make it abstract, because if you make it abstract, no one can create instance of your class. Number two, if you have a methods in your super class and you don't care about what subclasses will do, you don't have abstract method, therefore you should not have also abstract class. All right, so I think it's all about the constraint. Yeah, I'm writing my program. I want every class to have its own implementation of method X. If I make my method X abstract, definitely the whole class becomes abstract. And no class can create instance of that abstract class. It must be extended by some other classes to make sure that all the methods they are implemented. So removing the abstract classes and remaining with class C and B, would it change anything when they inherit from each other? So how can you remove the abstract class? Because again, it goes with the logic, what you want to do. Because my abstract class here is this class, and I have B. So if you look at B, I have option to override the content of those methods from a superclass. But if you look at the class C, I don't have method gradings, right? But if you look at the output, class C, welcome class C, okay, class C, that is show student details, welcome to AUKA, this is coming from a grading method. I don't have a grading here. I was inheriting it from my super class. So if you remove this one, then you remain with class B, then class
Recording
C,
in progress.
still that will be fine, but again anything you do will be fine, but again anything you do. So anything you do, it depends on which logic you want to work on. So I think that's what I can tell you, Nancy. So yes, you can remove. You can have a program without this class, and you have like a class B. Then you have a class C extending B. But that's your style. So if there is nothing common, if B is not inheriting from somewhere else, you may not need this one. So basically what you need to understand when we explain the concept, we want you to understand there is a concept of abstractions, abstract classes, when you can use abstract classes, but definitely judging where to use the concept will be up to you. All right, so you need to understand those constraints that we are trying to solve using abstract class. So whenever you write a program, whenever you work on a software project, and you find a need to use the similar concept to deal with those constraints, then this is why we decided to use abstract interfaces, polymorphism, encapsulation, all those. Just run the concept, and depending on the project, you may find them useful. Okay, so let's keep watching the chat room if there are any other question. Otherwise, I will go to the interfaces. All right. All right. So now let's look at interfaces. So the next topic is interfaces. So what do we mean by interfaces in Java? So we'll see how you declare interfaces. It is possible to for one interface to extend another interface. That is sort of inheritance between interfaces. So maybe we don't need a maker tag interface. We look at interface, how you declare interface, how you can extend interface, and then we'll see how you can compare interface and abstract. So those will be very useful. So maybe these two slides, they are not very important for you, so we this one and this one we will skip them. They're not very important, not at all. So what is the interface? Interface is similar to abstract class. Interface is similar to abstract class, except what? All methods in our interface, by default, those methods are abstract. Similar concept with abstract class, but the difference is all methods by default are abstract. So all methods are implicitly abstract and public. So whether you don't need to put a keyword abstract. So by default, we know the method inside interfaces, that method is abstract and public. So as we said for abstract class, also interface cannot be instantiated. What does it mean? You cannot create instance or object from interface. So we declare interface using a keyword interface. Like you can see here, we have animal. So we didn't use a class. We used just a keyword interface. And the method you have here, we don't need to use a keyword abstract. But by default, these methods are abstract and public. These methods are abstract and public. So that's by default. So implementation, how do we implement an interface? You remember for the abstract class, we need another class to extend it. So the same concept of inheritance. But for interfaces, we need the class to implement the interface. So we have a keyword implements. So this is animal class, and if you have a dog class, okay, dog will implement sound method, dog will implement void method. So as long as you put implements animal, it knows you must implement those method. Yes, you can add your own method here, but the most important thing is those methods specified in interface must be implemented from here. So let me know if it is clear so far, because it's very important. All right, so if everything is clear, Let's continue then. So you can have a multiple interface. You can have a multiple interface. So like here we have interface I with like one method M. Also we have interface G with method void N. So we can have one class to implement multiple interfaces. Like this class K is implementing both I and J. So what does it mean? Any unimplemented method here needs to be implemented here. So this is implementation of this method. And any method which is not implemented here has to be implemented also here. So this is what happens. So so now let's see. So when we use extend keyword, it has to be between interfaces. One interface can extend another interface, but a class can only implement interface. So in this case, you remember that we said that one interface can extend another interface. So what does it mean? If there is some method in this interface, so when this interface extends this method, what does it mean? From this interface here, you have both methods M and N. So this is normal as inheritance in classes. And any class like this one implementing this interface, that means it has to implement both methods M and N, because from here, logically, you can see that you have those two methods. All right, so this maker interface we said we skip. Let's look at the default methods. So when you declare interface, as we said, your method by default will be abstract and public. But also, if you want, you can have some definition of your method. Like here, void it. It's implemented, but we use a keyword default to indicate that this is default implementation. So which means what? Any other class which implements this interface, we still have to implement a make sound method and it method. So regardless of this implementation, because you remember, since it is an interface, anything you do, you have override. So override means what? You are overwriting the content of this method from either interface or from a super class. So also we said let's ignore functional interfaces for now. So let's focus on the difference between interface and the abstract classes. So as we said, for interface, all the methods are abstract and public, but for abstract class, you remember, can have both abstract and concrete methods. Interface can have some constant and variables, since you have also even default implementation of your methods. So interface can have only constant, cannot have variables. So, but in abstract class, you can have both constant and variables. So this is an example. Interface A, you can have something like this one, and you can have a method, and here you can have, but by the way, so we need to check this one, because here you can have only the variables but not a constant. You can have a variables but not a constant, but here you can have both. This is a constant. This is how you declare a constant in Java. So when you use static final makes your value a constant. So sorry for this example. We should have the content here should come here, and the content here should come here. So now let's go for some examples. Let's go for some examples. So now let's make some interfaces. By the way, you remember this one, eh? You can have everything in one file. You can have things as separate files. Like here, I can say maybe this is one interface. Add, okay, let's say student data. This is just one interface. And in this interface, what I want to do something like public void add new student, public void update a student, this is add a student. Also I can have a public void delete a student. Okay, I can have also public void show student by ID. So this is one interface. You can have another interface, let's say maybe we call it teacher data. So you can do the same. So for the sake of time, I can copy this stuff here, copy, paste. So it's not add the teacher, it's not add the student, it's gonna be add the teacher. You're gonna be update the teacher. You're gonna be delete the teacher. It's gonna be also show teacher by ID. So now if you have any other class, let's say, let's call it a class. I can call it data management, data manager. So this is a public class, will contain also main method. If I needed to implement some interface, by the way, you can come and click here and pick which interface. So we have a student, you can see interface student data. You can do this or you can write it. So it will come like this one. So if you look at my method here, it's implementing student data. And why is it complaining? If you mouse over here, you can see add unimplemented methods. So all those unimplemented methods will be the method from the student interface. So automatically I need to provide implementation here. So what do we mean by adding data student? I can put some simple text like here, add code to save student data in a database, for example. So you can write some code here. The point is just to implement that method with by overriding what was provided. So the next here, we are going to add some code to save data in the database. So add the code to update student data, for example, to update the student data. So you have a method there for delete. Add some code to delete the student data, and down here you can add some code for displaying a student to show student based on ID. So all right, so this is one, and if you want here, what you can do, those methods are not static, so you may need to have an instance of this class data manager dm new data manager, and you can do dm add the student. You can see what happens. Dm delete the students. You can do dm show student by id. You can do your data manager update the student, so you can see. So you can run your program here, run Java application, save all the classes. So now you can see it's calling all those methods, right? So you remember, why do we need to create instance of the same class inside the same class? It's because these methods add the student, they are not a static method. So since they are not a static method, you cannot access them directly. That's why you need to make, by the way, you need to make instance of the class. So can you try? Yeah, you cannot try it inside the static method. You cannot do this. You see there is a complaint because you are inside the static method. You cannot access non-static method inside static method. So that's why I needed to make a instance of this class. So let me check for some question in the chat room. No, someone is saying there is no voice. Is it from me? So guys, you can't hear me?
We can't hear.
Yeah, I think the voice, I should be audible, so I don't know what is happening. So you need to check your end. All right, so now you guys, you see what I said, eh? I decided to have my interfaces like separate files, but if you look at our PowerPoint presentation, you can even have them here. All right, but you will see for better visibility and readability of your program, it's always separate things like this one. Let's have another example here. So let's have another example. So guys, you can mute yourself as well because I'm trying to mute you, but that doesn't seem to work. But you should be able to mute yourself. I mean 23161. So please mute yourself because we are getting some background noise that we don't really like. Good. Okay, so I think you understand what I mean. So you can have these interfaces in one file as your main class, or you can separate them as I did here. So to make sure that your program is much readable, people can simply understand your program. So now, let's make another good example where we can implement many interfaces. So we make another class. Let's call it data manager 2, and we are implementing two interfaces. One is a student, and we add another interface that is a teacher. So it becomes like this one. So even if you don't use the IDE, you can write this like this one. Just implement the first interface and the second interface. So why is it complaining? Because we have an implemented method. So what are those methods? The methods in a student data class, in student data interface, and the methods in a teacher data interface. So you can add an implemented method. Now you see what you have. You have a teacher method. You need to make sure you implement those methods. And you have a student method as well. So I can quickly wrap this code here for the sake of time, and I simply paste and edit. So let me do this. I will paste. This is saving teacher data in DB. This is updating teacher data in DB. Update teacher data in DB. And here we have a code to delete. So can you mute yourself? Add the code to delete teacher data from DB. Here you can show teacher by ID to show teacher by ID, and down here you can add a student, add save student in DB, update a student in DB, to update a student in DB. And down here we have a method to delete a student from a DB, and here we have some code to show student by ID, So that's good. So if you want, this is one class, but there is not many method here. So you have different ways. You can have another class, maybe, and you make a call. You can do that. You can have another class to extend this. Everything is possible. So if you want, you can see this. Let's have a class. If you wanted to do those stuff, you may avoid things like public here. So just keep it as a class. That means you will need to have another class. So there are two ways. Simple one, we can have a public class. Maybe we call it show interface. Okay, test interface. Test multiple interface. Test multiple interface. This is my class, and I needed to add the main method. You can go to source code and generate. Let's see if you can generate main. If you can't generate main, you can write it yourself. Public static void main, whatever you pass as a string, whatever the argument. Alright. So, why is it complaining? The name of the class should be the name here. But this is a very long name, so maybe let's say test multiple interface, something like this one. So then we copy this name, we use it here. The name. Okay, where is the name? Refactor. Yeah, the name. Paste. So we are not updating any reference. Make it this. That's okay. It's gonna complain. No, we are not No, it should be renamed. Let's see. The name. So it's changed here, but now here it's complaining because even here it has this example. So doesn't matter. I can call it like A. So I want to demonstrate. Either you can have this in one file or you can have them as a separate. So basically you don't need this class if you can have this method in this class here. But if you do so, you still need to create instance of that class inside this class itself. But if you do this one, yes, you can say I'm creating instance of what is the name of class A, something like new A. So I'm creating instance of this class which is implementing my interfaces. So I'm making instance of it. Then from there I can make a call to all those methods. Add the teacher, sorry. Add teacher, yes, delete student, yes, delete teacher, yes, show student by ID, show teacher by ID, update student, update teacher. So you can see you can have a reference to all those methods. All right, so let's compile and see why this is still complaining. Let's save and see. No, there is no complaint, which means the program is okay. So if we run the program now, you can see should be able to call all those 8 methods. 1, 2, 3, 4, 5, 6. I think those are 8 methods. Yeah, 7, 8. So now well and good. So one interface can extend another interface. So let's come here and say let's have another interface. So we call this interface human. This is interface called human, and in this interface what we have one method, public void show details. So now since this is interface, if I come here for student interface, I can say extend. One interface can extend another interface. Extend human. So this interface is extending human interface. So what does it mean? Let's do the same for teacher. Teacher interface also extend human. So what does it mean? The same concept of inheritance. This, on top of this 4 method, it has also access to this method here. Okay, should be clear. So let's save and see what happens. So if you save now, we go to data manager, we have a problem. We go to test multiple interface class, has a problem. So what is the problem here? So now you see we did implement 4 methods, but since our interface is extending another interface, there is one method which is not implemented. And what is that? The method here. So we need to have implementation of show details as well, because this interface now has how many methods? 5. 4 methods here plus another method from this super interface. The same here. The same here. We have 5 methods, 4 here plus 1 method from this interface as well. So the comprehend in our classes, we need to add an implemented method, and we will see which method. I'm adding that method, show details. This method called show details, it's coming from which interface? From a human interface. So I wanna copy and paste it here. Okay, show details from human interface. Show details from a human interface. So the same comprehend, because like here the comprehend is gone, but we still have a comprehend here. So the same comprehend comes here. This class A is missing one method. What is that? You can see I've added it. Where is it? Yeah, it's here. So we needed to provide implementation. So this is a quick demonstration. Put any content. So do that something like this one. This is the show details from a human interface. So now you understand. So if we save, the complaint is gone. Run your program and see. Run Java application. So you can see that we have also. No, we did not call this method, right? We needed to call it also. Where are we calling other methods? Here, we need to say a show details. All right. So we need to do the same here. We are calling other methods. Also, we need to call that method as well. Show details. Good. So let's save. And you can run any of those programs. Alright, so show details from a human interface. So what you see, let's summarize in this demonstration. What you see, one interface, this simple example, interface can be implemented by a class. So you cannot create an instance of your interface, you can only create an instance of your class which implements your interface. That's one that we covered today. Two, you can have a class which implement multiple interfaces. You can see you're implementing more than one interface. So that means you need to implement all the methods from each of those interfaces. Number three, we have seen that an interface can extend another interface. So logically, you should understand how it works. So this is what we can do today. So next time, we talk about the collections and exception handling, and then that will be more than enough for our semester. So we talk about exceptions, the collections, mainly array list, and exception handling. This is stuff of try and catch. That's what we do next time, and that will be like the end of our content, by the way. So we remain with discussions and questions. So let me stop recording.